Hello everyone, I welcome you all in the logical learning platform. In this lecture, we will discuss simplex method for linear programming problem. So look at this problem. Here we have to minimize z and these are the constraints. As I already told you in previous lecture, how can we convert a given LPP into standard form? So first step is to convert a given problem into its standard form. So for this, we'll convert this minimization to maximization and we'll convert these inequalities into equations. For this, you can go to the previous video. So here is the standard form of this LPP. Maximize z dash. Z dash another variable where z is equal to minus z. So here it is positive, here it is negative. And these are the constraints we have added S1, S2, S3. All these are slack variables because inequalities are less than equal to. So this is the first step to convert given LPP into standard form. Now the second thing. Now look at this. How can we write? We can write it as maximize z dash this equal to cx subject to ax equal to b. Now what is c? C is basically the vector of, you can write it. This is the vector of the coefficients of x1, x2, x3. You can write it minus 1, 3, minus 2. Look at this here. S1, S2, S3 are not there, but there we can write. If you wish to write all these variables here, their coefficients will be 0. So you can write it 0, 0, 0. So this is basically C. And X is, what is X? This is, you can write this is X1, X2, X3, S1, S2, S3. So this is C and X. Now A is the matrix of the coefficients of these x1, x2, x3. In this matrix, if we form the matrix of all these equations, this system of equations can be written as ax equal to b, where a is the coefficient matrix, x1, x2, x3, s1, s2, s3. You can write it in the form of this transposition also x, and b is basically 7, 12, and 10. So here these are the notations. Now we have to find second step to find the initial basic feasible solution. How can we find this one? Now look at this. Here we have three equations, and number of variables equal to number of variables equal to 1, 2, 3, 4, 5, and 6. This equal to 6. So equations are 3, but the number of variables are 6. To solve this system of linear equations with 6 variables having 3 equations only, we cannot find a unique solution. So you can choose any 3 variables. Extra variables equal to 6 minus 3. This equal to 3. Extra variables. This equal to 3. So you can choose any 3 variables out of these and find the solution of the remaining 3 variables. Because if you choose any 3 variables and put them 0, then you will get 3 equations and 3 variables. Now the question is, which 3 variables should we choose? So for this simplex method, we start with assuming x1 equal to 0, x2 equal to 0, x3 equal to 0. Why we are doing so? Because here we are talking about basic solution also. Feasible means possible. Basic means when we can say a solution is basic. Now look at this. If we put x1 equal to 0, x2 equal to 0, x3 equal to 0 here, what we will get? All these are 0. It means s1 equal to 7, s2 equal to 12, and s3 equal to 10. s3 equal to 10. So look at this. Here A is the coefficient matrix. The matrix corresponding to S1, S2, and S3. What will be the matrix corresponding to S1, S2, S3? The coefficient of S1 here, this is 1. S1 is missing from second, so coefficient is 0. S1 is not there in third, so again its coefficient is 0. Now for S2, S2 is not in the first one, so 0, 1, 0. For S3 it is 0, 0, 1. So this is the part of A corresponding to S1, S2 and S3. So this is a part of A only. I have not written all these coefficients. I have written only the part of A corresponding to S1, S2 and S3. Now look at this. This solution where x1 equal to 0, x2 equal to 0, x3 equal to 0 and s1, s2, s3 and some values, and the corresponding matrix A with respect to s1, s2, s3 is a unit matrix. If this is a unit matrix, then we will say this solution is a basic solution, and these variables are basic variables. These variables are basic variables, and these variables are non-basic variables. These variables, so x1, x2, x3 are non-basic variables. S1, S2, S3 are called basic variables. When we say these variables are basic variables, when look at this equations again, check it. Equations are 3, number of variables are 6, extra variables are 3, and we have started with x1 0, x2 0 and x3. Remaining variables are s1 equal to 7, s2 equal to 12, s3 equal to 10, and the matrix corresponding to s1, s2 and s3 is a unit matrix. Only then we can say S1, S2, S3 are basic variables. If it is not a unit matrix, just assume if it is -1, say, then it is not a unit matrix. So in this case, you cannot say that these variables are basic variables. So you can say these variables are basic variables only if the corresponding part of matrix is a unit matrix. So remember this. This is very important because suppose in case if inequality is greater than equal to, then this will, here you will add surplus variable and it will be minus s1, not s1. So if it is minus s1, then this will be -1. So if we put x1 equal to 0, x2 equal to 0, x3 equal to 0, we will get s1 equal to -7, and this corresponding entry will be -1. And in that case it will not be a unit matrix, so you can't say it is a basic variable. So this is very important because based on this we decide whether to apply the simplex method or its modified version. So here it is the initial basic feasible solution. Remember one thing, non-basic variables will be 0 every time and the basic variables will have some values. If one of the basic variable is 0, then we say the solution is degenerate solution. If one of the basic variables is 0, then we say the solution is degenerate. Now look at what is the procedure of the simplex method. If you see x1 0, x2 0, x3 0, this is basically the point of origin. It means we are starting from the origin point. Just like as in graphical method, we move from corner to corner. Here in the simplex method also, we move from corner to one corner to another corner. We start with this origin point. So if the optimum value is at that point, it's fine. Otherwise, we'll move to another corner. Another corner means this solution will be updated. Now, one variable from basic solution, basic variables will move. One variable from basic variable will move into this non-basic, and one variable from non-basic will move to basic variables. In this way, this set of non-basic variables will be updated and will move to the another corner. So for this, how can we do? We create a simplex table. Now look at this, the form of the simplex table. Now look at this, these are non-basic variables, these are basic variables. This maximum z dash equal to cx. Now look at this, maximum z dash this equal to cx. How can we write? Now we have two parts of c. One is corresponding to non-basic and another is corresponding to basic. So you can write it C non-basic x non-basic plus C basic into x basic. As I told you, all the non-basic variables are 0. It means the first part is 0, so remaining part is CB XB only. So where CB is the coefficients of xi's and XB is all these variables and their values. So maximum z dash can be calculated as CB XB only. Now you will see this here in the table. So this is the form of the table. Now look at the C here, as I told you, Cj for the column. So there is first column, second, third. So these are the coefficients. C1, look at this here. This is -1. This is 3, -2, 0, 0 and 0. So these are the coefficient C. Basic variables. In the starting initial basic feasible solution, the basic variables are S1, S2 and S3. So we'll write here S1, S2 and S3. And these are the coefficients of basic variables. If you see, the coefficients of basic variables are 0, 0, 0. So here you will write 0, 0, 0. Now what is XB? XB is the initial. These are the basic variables. Basic variables are S1, S2, S3 and their values are 7, 12 and 10. So these are basic variables. CB means for basic. XB means basic variables. These are coefficient and these are values. So if it means initially if we wish to calculate Z, look at this CB XB. So how can we calculate 0 into 7 plus 0 into 12 plus 0 into 10? So initial value of Z is equal to 0. Now we need not to go back to the equations. From the table we can calculate Z. It is not Z dash. You will write it Z dash. Now so these are the coefficient and these are the values of basic variables. Now x1, x2, all these variables are here and these are the coefficients of x1 in these equations. So you can say this one is basically A. This matrix A is here. So these are the coefficient of x1. Look at this 3, -2, -4, x2, -1, 4, 3. And this part, look at this is 0. And this is wrongly written. This is 1. So you will correct it. So 1, 0, 1, 1, 1. So this is a unit matrix corresponding to S1, S2 and S3 because these three are basic variables. So this is the first table. So how can we check whether this is an optimum solution? So now look at this. So this is the table. Now to check here Z dash this equal to 9. To check whether this solution is optimal solution or not, we calculate delta J for column. So for each column we calculate delta J. What is delta J? This is J minus Cj. Now what is Zj? Zj is basically the dot product of the Cb and the jth column. For example, delta 1, if we wish to calculate delta 1, how can we calculate Z1? Z1 means Cb dot x1. Cb dot x1, that is 0 into 3, 0 into 3 plus 0 into -2 plus 0 into -4. So this equal to 0. So this is Z1. So Zj, you can write it. If I talk in the term of rows also, so you can write dot product means sum of all these products. So if you assume R for rows, R equal to 1, 2, 3, here 3 rows are given. So you can write CBR, R for row. So this is CB1, CB2 and CB3 dot XRJ, R for rows and J for column. So this is the dot product of CB and Jth column. Now minus Cj. So in this way you will calculate delta J for each column. So for example, look at this delta 1. So all these 0, 0 is 0. Here I have calculated Z1. So this is 0. 0 minus -1. So look at this delta 1. delta 1 is z1 minus c1. So this is 0 minus minus 1. So this is plus 1. So here it is plus 1. Similarly, this dot product is 0 because all these entries are 0. So this is minus 3, this is 2, this is 0, 0 and 0. Now remember one thing, if all delta j's are greater than equal to 0, then we will say the present solution is an optimum solution. If at least one negative value is there, it means the present solution is not optimal. And if you are sure that present solution is not optimal, then you will choose the most negative value of delta j. Here the most negative is minus 3. It means the corresponding this variable x2 will enter into the basic variable, and one of the variable will move out from the basic variable. Again, listen it. You will choose the most negative value of delta j, and the corresponding variable will enter into the basic variable. One basic variable will move out from the basic variables. Now, which variable will move out? For this, we calculate ratio of xb, and this incoming, the vector of this incoming, that is x2. Now here is one condition is there, you will calculate the ratio only if this value is greater than 0. It means if I write in the term of columns, so you will calculate the ratio of xbr upon xr2 provided xr2 is greater than 0. xr2 is greater than 0. So you will calculate this ratio only if this value is greater than 0. Otherwise you will leave as it is. So the first ratio, look at this xb, this is xb1, this is x, this is the value of first value of x, the second column. So it is minus 1. So we'll leave as it is. We'll not calculate the ratio because this x12, this is negative. Now here 12 upon 4. So this is 12 upon 4. This equal to 3, and here 10 upon 3. This is 10 upon 3. This is 3.33. Now we'll choose the minimum value of these two. So minimum value of these two is this one. It means this variable will move out from the basic variable. So in this way we can calculate the incoming variable and the outgoing variable. Now once we have calculated these two things, we will create the next table. So how can we create the next table? Now look at this. This S1 will remain here in place of S2. Now X2 is coming here. So you will write X2, S3 will remain as it is. So coefficient of S1 0, coefficient of X2, you will see this is 3. So you will write 3, X3, this is 0. So these are fixed. These are the coefficients. So you will write from here. Now all these values, we will calculate all these values from the first table. So how can we calculate? Now look at this. This is incoming vector, this is outgoing, and this is the point of intersection of these two. So you will write here an asterisk or star mark. This point is known as key element or pivot element. Whatever you wish, you can say it, key element or pivot element. Now look at this. X2 is taking place of S2, and S2 is 0, 1, 0. As I told you, the part of this basic variable must form this unit vector. So this is 0, 1, 0. Now it means we have to make X2 as S2. That is, it should be 0, it should be 1, it should be 0. The focus is in this element. That's why we are saying it is a key element. We have to make it 1. It means, and the rule to make it 1 is divide this value by whatever given here, whatever the value given here, so divide it with the same value, then you will get 1. and you have to apply the same rule to the entire row because all these values are related. So means we have to create the rules for this row. So this is R2, say this one, this rule R1, R2, R3. So rule for R2, this is R2 divided by 4. So you can calculate it. So this is 12 divided by 4, this is 3, this is, now look at this, this is minus 2 divided by 4, so this is minus 1 by 2. So this is 1, this is 0, so 0, 0, this is 1 by 4 and 0. Now look at this, we have to make this element 0 with the help of this element. So how can you make it 0? We are not going to change this element. We have to change this element and we have to make it equal to minus 1 or 1 so that we can add or subtract it. So how can we frame the rule for R1? We are not going to change R1. Look at this. So we have to divide it by 4 so that it will become 1. So if you divide R2 by 4, it will become 1. This is already minus 1. So what we have to do? We have to add. It means now you have to add 7 plus this divided by 4. Now look at this, we have already calculated R2 by 4 here in this row. So it means you have to add the elements of this and this one because this is R1 and R2 by 4 is this one. So 7 plus 3, this is 10. 3 minus 1 by 2, if you calculate 3 minus 1 by 2, this is 6 minus 1 by 2, this is 5 by 2. So here it is 5 by 2. So minus 1 plus 1, this is 0. 3 plus 0, this is 3. 1 plus 0, this is 1. 0 plus 1 by 4, this is 1 by 4. 1 plus 0, this is 1. Now for this one, we have to make this element 0 with the help of this. How we can do it? R3. So R3, look at this, this is 4, we have to make it 3. So we will divide it by 4. So first R2 divided by 4, it will become 1. We have to multiply it by 3 so that it will become 3. Now both are in positive sign, so we have to subtract it. So R3 replaced by R3 minus 3R2 by 4. So now we will calculate this element R3 minus 3R2 by 4. So R3 minus 3R2 by 4, look at this. We have already calculated this row is R2 by 4. It means we have to multiply it by 3 and subtract it from 3. So first element will be 10 minus 3 into 3. That is 10 minus 9. This is 1. So this becomes 1. So this is 1. So first element is, this is 1. Now look at this element. Here it is minus 4, minus 4, minus 4, minus 3 into R2 by 4. This is R2 by 4. So this is minus minus plus 3 by 2. So look at this is minus 8 plus 3 by 2. So minus 5 by 2. So this is minus 5 by 2. Similarly, look at this 3, 3 and this is 1. This is basically R2 by 4. So 3 minus 3 into 1, 3. So this is 0. Similarly, you can calculate other values. You will see this value is, here it is, this is 8, this is 0, this will become 8 and this is 0 and this is, look at this value is 0 minus 3 into 1 by 3 by 4. So this value is minus 3 by 4 and this becomes 1. So these are the updated values. Now you can calculate Z dash. This is 0 into 10, 0, 3, 3, 9. This is 0. Z dash, this is equal to 9. Now calculate delta 1. 0 into 5 by 2, 0. 3 into minus 1 by 2. This is minus 3 by 2. And this is 0. Now minus minus 1, that is plus 1. So this is minus 3 plus 2 by 2. So this is minus 1 by 2. So this value is minus 1 upon 2. Now for delta 2, 0 into 0, 0. This is 3 and 0. So this is 3. 3 minus 3, this is 0. So this is 0. And similarly, this value is this one CB into x3, this is 0. This is 0, 0. And 0 minus minus 2, this is plus 2. Similarly, other values are, if you calculate 0, this is 3 by 4 and this is 0. Now look at this, one value is negative, it means this solution is not optimal. Most negative is this one. And now to calculate the outgoing, this x1 is incoming. Now to calculate outgoing, we will calculate the ratio xb by x1. Look at this, these two values are negative, so only one ratio will be calculated, 10 by 5 by 2, 10 upon 5 by 2. This is 20 by 20 by 5, this is 4. Only one ratio is there, so only this is the vector. So this is the variable and this will leave out the basic variables. So it means now we have to create another table. Then this element is the key element. So we will repeat the same procedure here. So this is the table number 2. I have written all these values here. So you have to repeat the same procedure again, and this is the key element. This is outgoing and this is incoming. It means in the next table, now in place of S1, you will write X1, this will remain X2, this will remain S3. So you will write the row operations. It means first, how can you apply row operations? 5 by 2 for R1, you will write, you have to make it 1. So you will write 2 by 5 R1. Now look at this. This is the operation for first row, and for the second row R2, you have to make it 1 by 2. So for this, you have to divide it by 5. If you divide it by 5, it will become 1 by 2. So this is, here you will write R1 by 5. It will become half. This is already negative. So you will write R2 plus R1 by 5. Now for R3, look at this. This is negative and this is positive. So we will edit R3. So R3 plus R1. So these are the row operations. So if you write all these elements, coefficient of x1, this is minus 1, x2, this is 3, and for s3, this is 0. Now xb, we have to calculate first r1, 2 by 5. So if you calculate r1, this becomes 4. This is 1, 0. This is 6 by 5. This is 2 by 5. 6 by 5, x1, x2, x3 is 6 by 5. This is x1, you will calculate 1. This is 0. This is 6 by 5, 2 by 5. This is 1 by 10. And similarly, you can calculate all other values. This is s3. This will remain 0, and you can calculate all other values. So now I directly go to this table. So I have calculated all these values here. So here you will see all delta z's are greater than equal to 0. It means this solution is the optimal solution. We need not to move further. Now from this table, how can we write solution? X1 equal to, you will see this is 4. X2 equal to, this is 5. Now look at this x3. In the initial problem, if you will see x3 is there, x3 is there if you see. But in the last table, if you see, x3 is not there. It means x3 is in the non-basics. And as I told you, the value of non-basic will be 0. And the maximized z dash, this equal to 11. But originally we have to calculate minimum value of z, this is minus 11. So this is the solution of the given problem with minimum value of z equal to minus 11. So I hope that you got the concept of the simplex table. Thank you.